Yellowstone Park caldera is not a good sign. Take very seriously these data points and ask yourself, would you be prepared if this blew? I watch these charts daily and this kind of violent movement says to me, the magma is moving. Just like the supervolcano in Japan went off, the Yellowstone volcano may be next. In addition, a new vent opened up recently that goes right into Mount St. Helens. Scientists believe that the helium is slipping out of rocks that were formed during the Archean, about 2.5 billion years ago. But now they are coming out again from Yellowstone Park, not a good sign. Yellowstone releases gases ranging from carbon dioxide to methane. Not only was there a sudden rise in the elevation of the ground and development of new cracks, but a gas called helium-4, a very rare type of helium, has begun coming out of the surface. Bill Evans, a researcher with the USGS in Menlo Park, California, explained how the helium is released. Volcanoes most always form on the edges of tectonic plates that make up the Earth's crust. Yellowstone sits directly over the middle of a plate. It's a part of the crust that formed a very long time ago, billions of years ago, and it's basically been stable since that time. They've had this boring, peaceful existence and now suddenly they're put on the front burner. The animals and birds have been dying off and now are we all in danger? This is the chemical, helium-4, that was seen prior to many recent volcanoes erupting. Measurements from other GPS stations in northern Yellowstone show smaller displacements, forming a circular pattern of deformation, circular, as in the round mouth of a volcano, consistent with a minor pressurization, building up underground, about 6 to 10 kilometers, 4-6 miles, deep, near Norris Junction. The volcanic island of El Hierro, the smallest of Spain's Canary Islands, rumbled and groaned over the course of 7 months in 2011 and 2012, gases silently percolated up through the island's soil and groundwater. Eventually, a spectacular plume appeared off the southern coast of the island, a sign that El Hierro volcano, an underwater volcano just offshore, had finally erupted. We believe that helium can anticipate the detection of magmatic movement even before those movements can be detected by seismic activity, said Eleazar Padron, a geochemist at Spain's Technological Institute for the Renewable Energies, who led the work.
Can the Yellowstone supervolcano be stopped? It is the largest supervolcano in the entire world. NASA has come up with an ambitious new plan to cool down the supervolcano by using it as an energy source. Sounds like some kind of desperate effort to stop the coming eruption. The natural beauty of Yellowstone National Park attracts thousands of tourists each year, but not far below the surface is an increasingly large chamber of molten hot magma that could erupt at any time, containing as much as 200 to 600 cubic meters of molten rock, enough to fill the Grand Canyon over 11 times. This vast subterranean cavern is part of one of the largest known supervolcanoes. When it erupts, it will cause untold devastation across hundreds of square miles and impact the climate on a global level. Those of you that are lucky enough to follow my blogs have known that there's an increase in activity. This is the chart from yesterday, the spectrogram, showing the magma, the gas, coming in, rising up from the chamber. I've told you about the unprecedented uplift that's currently going on at Yellowstone Lake. This is the north direction, showing the deformation of the ground. This is east. The uplift at Norris Junction, which has been going on since before 2014. This is an image of the caldera rim. This is where the current earthquake swarm's been going on. 2 kilometers in depth is the magma. That's actually only 1.24 miles in depth. The center of the caldera, we have Yellowstone Lake, we have the Resurgent Dome, Mallard Lake where Old Faithful is located, Sour Creek Dome at the south end of Yellowstone Lake. 8 kilometers in depth. The magma is actually only 5 miles under your feet. Over here we would also have Maple Creek, Norris Junction, all very popular spots for people to view the geysers. 1.24 miles underneath your feet is the magma. Now, in a renewed bid to stop this from ever happening, the eruption, scientists at NASA have come up with the ambiguous plan to turn the supervolcano into a near limitless source of geothermal energy. What could go wrong? They're going to frack. And what does fracking cause? Earthquakes. So their plan includes drilling a hole. It would be needed to drill into the side of the volcano so that water can be pumped through. When this water comes back out, it will be superheated to over 600 degrees. It might take hundreds or even thousands of years, but if this is done enough times, the volcano will slowly cool down until it reaches a point at which it no longer poses a threat, according to NASA. With the time left before an eruption ticking away, NASA is hoping to implement the plan soon. They say if it works, it could provide enough energy to power the entire region for centuries to come. So here we have the park, right there. This is the caldera that they know of so far, and notice it extends beyond what the recent studies that were done in 2015. They're going to try and cool down the volcano to prevent an upcoming
archaeological
eruption.
paper by the Geological Society of America titled, Future Volcanism at Yellowstone Caldera, proposes that past emissions have originated from profound inside the volcano and they have happened quickly. The paper says, these source areas concur with the upper parts of the present-day image magma chamber, while the shortcomings concentrate a significant part of the present-day caldera agitation. In light of these joint perceptions, we suggest that volcanism has a higher likelihood to continue in three blame-controlled NNW slanting lineaments, the principal agreeing with the western caldera edge, the second lying over the focal locale of the caldera, and the third stretching out over the northeastern caldera. The initial two lineaments centered late intracaldera volcanism, 174 to 70 Ka, while the last is the most dynamic as far as present caldera turmoil. Future volcanism could incorporate vast-volumed magma streams and phreatomagmatic rhyolitic emissions. The recognizable proof of these three districts together with conceivably quick eruptive systems may better characterize future observing endeavors important to enhance emission anticipating in this huge range of volcanic distress. This means science is just start to see exactly how unstable Yellowstone is, however doesn't yet know how it will next emit or when. Read the first paper, Future Volcanism at Yellowstone Caldera, Insights from Geochemistry of Youthful Volcanic Units and Observing a Volcanic Turmoil.